Hello and welcome to the second video where I will be discussing balancing and degrees of freedom. So first of all, there is a term called basis of calculation. So let's assume in the normal ammonia plant, I'm considering only the reactor and the stream back. It can be applied to a general process as well. So yeah, let's say that I'm given that the ammonia production is, let's say, 100 kilomole per day. Okay, so what I need to find out is, let's say that purge is not there, and how much amount of nitrogen and hydrogen will be required for, let's say, 50% of conversion. So if that is the question, so instead of starting from 100 kilomole per day in the end, you can do one thing. You can start off with uh, x and 3x. Instead of x and 3x, you can be even more specific. You can keep x equals to 100. It can be any number of your choice. X can be even 10. Okay, so you can take your some specified x, which simplifies the calculation. Then you do all the calculation and you find out, if x was 10, what is the amount of ammonia out. So if, let's say, the ammonia comes out to be, let's say, 20, so but we need 100, so we just multiply it by 5. So we multiply everything by 5. We multiply here by 5, we multiply here by 5, whatever goes here, we multiply that by 5, we multiply everything by 5. So the initial assumption what you take here is called the basis. So basically you would take a basis of calculation, which means you consider some value of the input, or some place you take a value according to your choice, and then finally multiply it with a scaling factor so as to match the condition given in the question. That is about basis of calculation. Now we'll talk about ways of balancing. In ways of balancing, there are three types. One is extent of reaction, one is molecular balance, and one is atomic balance. As the terms are evident about their meaning, extent of reaction, you take some basis of reactant, or maybe it's given in the question, and then you say that this reaction has taken place to an extent of eta or epsilon, that it has not, epsilon is equal to 1 means complete reaction, epsilon equals to half means 50% conversion. So you take an extent and write everything in terms of this extent of reaction and then solve the question. Molecular balance is the general way which everybody uses. Molecular balance is you take the concentrations of different species and then compute the balance. Atomic is basically you balance across the atoms. So there's one very nice thing about atomic balance is, if you are considering molecular balance, you don't know that how much is reacted. You don't know that how much is reacted. But atomic balance, you know that reactant is equal to 0, which means the number of atoms of any element is going to be constant. As we are not considering nuclear reaction, the reacted component is already 0. That's why we generally use atomic balance when we are going for multi-phase reactions, or when we are sorry, not multi-phase reactions, when we are going for multiple reactions together in the same system. Okay, now there is one general statement which says uh, the maximum number of independent independent equations that you can get out of material balance is equal to number of species. So let's say that in a distillation column, I'm considering simple distillation column, and you are, let's say, benzene and toluene, and you are getting some B1T1 and some B2T2. So how many reactions you can write across this? How many balances? So you can balance B, you can balance toluene, and you can balance the total mass. But the thing is, what this statement says is the total mass balance will be a sum of balance of benzene and toluene, and it won't give any extra information. So since there are two species, benzene and toluene, the total mass does not give. So you can either do benzene toluene, or you can do benzene and total mass balance, or you can do toluene and total mass balance. But you cannot do more than two on a given species. That is one thing. Now, what is degrees of freedom? Degrees of freedom is number of unknown minus number of constraints. This number of constraints also includes number of independent equations. So this is degree of freedom. So basically, degree of freedom, that is how many things you can choose. So let's say that we consider on water, steam, and ice system in which all three are in equilibrium. So that is a triple point. But at triple point, the temperature and pressure are itself specified. You don't have the freedom to change any of them. So that is degree of freedom equals to 0. In the same way, degree of freedom is how many things we can change. So number of unknowns minus number of constraints. So basically, when you are given a question, I don't want degrees of freedom. Whenever degree of freedom is equal to 0, it means that question is solvable. When degree of freedom is less than 0, which means there is excess information, or you have taken too many independent equations which are not independent. If it is greater than 0, which means more information is required. So that's about degree of freedom. And from where all you will get degrees of freedom, you can get from material balance, you can get from energy balance, you can also get from other data which is given in the question, like maybe gas laws, some data values, let's say h of evaporation of water, or some process specification like 100% conversion, or the complete carbon is converted, or things like that, or stoichiometry. So yeah, that's our degree of freedom analysis. And then you have different degrees of freedom equations for the three kinds of balances. For molecule balance, number of unknowns plus number of independent reactions, not independent equations, independent reactions, minus number of balances, number of independent balances, minus other data. Other data includes all these things: gas laws, process specifications, stoichiometry, is equal to degrees of freedom. Now, this number of independent reactions is in a way extent of the reaction, that we don't know that how much the reaction has gone forward. That is one thing. Okay, then for atomic balance, this thing won't come. So you have number of unknowns minus number of atomic balance minus number of inert species. For inert species, let's say that N2 is there in a sulfuric acid plant, so it won't react any place, right? So you can balance it separately. You don't have to consider nitrogen atoms. You can directly consider nitrogen molecule, because it's not breaking, it's not getting formed. Minus other data equals to degree of freedom. Then you have the extent of reaction method. Again, number of unknowns plus number of plus extent of reaction for each reaction minus number of independent balances minus other data is equal to degree of freedom. So basically, there can be important questions which ask that what is the degree of freedom for this system, and you don't have to solve the question, but you just need to find out degrees of freedom. So that's going to be an easy question. Make sure that you're very clear with this concept. Okay, then I'll end this video right here. Thank you.